A team of South African scientists using the South African Radio Observatory or SARAO MeerKAT radio telescope has spotted a rare and extremely faint radio glow coming from a huge cluster of galaxies about 7 billion light years away. This type of glow, called an ultra-steep spectrum radio halo, is the most distant one ever found. The discovery, led by Isaac Magolego, a PhD student at the University of the Witwatersrand, supervised by Professors Deane and Kshitij Thorat from the University of the Witwatersrand and the University of Pretoria, respectively, has been accepted for publication in monthly notices of the Royal Astronomical Society letters. The student project is supported by the SARAO. For more on this, Magolego joins us now on the line to tell us more. Isaac, thank you for joining us. How are you?
I'm fine, thanks. How are you? And thank you for having me.
Thank you
Can you hear me?
for making time for us. Tell us more about this PhD. In fact, we should be starting by saying congratulations on work well done. And then tell us
Thank you.
about your PhD study and how long it took for you to conclude it.
So I am currently doing my final PhD in physics. I specialize with radio astronomy at the University of Wits, Witwatersrand. I am 2 years, 5 months in. So yeah, so the duration of a PhD is 3 years. The normal duration is 3 years. So I'm not yet, I haven't submitted yet, but we plan to submit before the end of December. And my project is based on the synergy between MeerKAT and the South Pole Telescope, in which I'm looking or searching for diffuse cluster emission in radio clusters, in galaxy clusters. And that's what led to the discovery that I'm going to talk about today. So my project is strictly on diffuse cluster emission on galaxy clusters. I search for it through a systematic search throughout the MeerKAT South Pole Telescope survey, which is a 100 square degree survey that we use.
Is this an everyday thing, the search for these halos? Tell us about that process. How often do you search as scientists in this particular field, and how often do you find what you're looking for?
Not always. So for us, we have a huge sample of galaxy clusters that were detected first by the South Pole Telescope. And what we do is we use MeerKAT. MeerKAT is a radio interferometer telescope which detect synchrotron emission. It's like diffuse radio glow. So most of the time, so it depends on the sensitivity of the telescope and how long the observation was to observe a particular target. So if your observation time was not long enough, you might not be able to make a detection. So in our case, we had a survey, and these galaxy clusters that I'm studying were observed blindly. So none of them were targets. So they were just along or embedded within the survey that we observed. So it's not every day that you get a detection. So it's very rare, especially for this discovery that we made, given the distance at which it is located. We were able to detect it in just 1 hour of observation, but blindly, it was not really the target. So yeah, it depends on the sensitivity of the telescope. Because I have a sample of them, a lot of them didn't host any radio glow, only a few, and the one that I am reporting today is the most prominent one, and it happened to be at the furthest distance ever detected.
So what does this discovery initially mean, and what will it add in terms of scientific research and advancement in this field? You say it's quite a prominent glow that you discovered, this type of glow called an ultra-steep spectrum radio halo. How significant is it?
So the detection is of high confidence, and first of all, for being observed in 1 hour, and blindly so, and we made this detection. This tells you a lot about the radio interferometry in terms of the MeerKAT telescope is impressive. A lot of telescopes wouldn't make this detection, but in terms of the science, it pushes the boundaries of astrophysics. because the known ultra-deep spectrum radio halos that have been reported in literature before this one, they were all nearby, meaning at low redshifts. Their distances were not that far. So ours is so far that if we look the cosmic look-back time, it is half the age of the universe. The universe is about 13.8 billion years. The age of this halo is about 7 billion years. So that tells us a lot about these kind of processes that makes these radio halos come to life. So these processes are normally they are not favored in the early universe or at high redshifts because in the early universe there are conditions that make this kind of glow almost impossible to detect. And the fact that we were able to detect it with MeerKAT is just impressive on sensitivity front. But scientifically, it tells us that the energy processes that are driven by turbulence. So turbulence is the one of the models that have been proposed for these kind of halos that they will be detected with the next generation of telescopes. This was like 2 decades ago, and we now have those sensitive telescopes we are able to detect. So that's one. But it tells us that in the physics or cosmology terms, it tells us that the energies that are responsible for mergers or for collisions that gives rise to the turbulence that give rise to radio halos, these processes were already happening in the earlier universe than expected, because all the ultra-deep spectrum radio halos that were reported in literature, all of them were nearby. So having this one at the high redshift tells us something about how the large-scale structures in the early universe formed and how they evolved as to how we see them today. So it contributes to the models of, or the theoretical models of formation of halos and how they evolve.
What's next for you then, Isaac, after this very interesting discovery?
So our next goal is to search or to find more of these rare halos, especially at high redshift. And to do so, we need to expand the survey and look for more of them. Because in this survey, it's a 100 square degree survey, we were able to find only 2. But here I reported the one with the highest redshift, of course, because it's record breaking. We were only to find, we found 2, but we hope to find more if we expand the survey at least to more square degrees. So we're gonna try to find them, and then with the upcoming SKA, I'm not sure if you guys have heard about the Square Kilometer Array Observatory, which is currently they're busy constructing more telescopes to add to the MeerKAT. And the MeerKAT will be added to the SKA observatory. So with that upcoming set of telescopes that will be more sensitive than what we have already, we will be able to search for these kind of sources across
Very
the universe,
fascinating.
and yes, and understand how common they were in the early universe. And then from that, we'll be able to draw some like conclusions. If we have a huge sample, we can make some very big conclusions, and how we can constrain the models that actually favor the formation of radio halos, because
Isaac,
there's a
thank you
lot
so
of
much for
models.
your time and for chatting to us on this very fascinating topic. Very interesting things you do there. Isaac Magolego, a PhD student at the University of the Witwatersrand. Let's get our news headlines. Here's Onele Nzinzi, 8:31 Central.